Assalamu alaikum everyone. Welcome to the course Software Construction and Development. Today we will start our first lecture on software development process. Before starting the lecture, I would like to introduce myself. My name is Muddasar Yasin and I am from Department of Software Engineering, Engineering College. If you have any queries or questions regarding to the lectures, regarding to the topics which will be covered in this course of software construction and development, you can ask me through email. I have mentioned my email in this slide. Otherwise, you can also visit me personally in my office, which is in male faculty room, Engineering College. I will be available for the students to answer their queries, their questions regarding assignments, regarding lectures, regarding any topic of this course. You can visit me on Monday from 9:50 to 11:15 and on Thursday from 11 to 1 p.m. So first of all, I have mentioned some recommended books for this course. These books will help you out to understand the complexity of the topics which will be discussed further. So the first book is Clean Code by Robert C. Martin, which focuses on writing high quality maintainable codes. The second book is Working Effectively with Legacy Code. This book will help out when we will be discussing the topic regarding how we can use the legacy codes, how legacy codes help us to decrease the complexity of any problem. So we will be using this book at that time. And the third book is The Pragmatic Programmer by Andrew Hunt and David Thomas. This book gives practical advice for becoming a skilled software engineer. So these books are not limited to this course only. You can also take some help from these books throughout your degree in software engineering. So let's start our topic. The first and most important thing is that we are going to start with the definition of a software process. That how would we define a software process in software engineering? So a software process is basically a structured set of activities required to develop a software system. So basically we are working on a software system and we want to follow a specific structured activities which will help us to decrease the complexity of that problem. So basically this is the definition of software process. Whenever we build software, we don't just sit down and start coding. It is not a good practice that you listen to the problem rather than doing your preliminary work on that problem, that what resources are required, what will be the cost of this project. You directly start coding that problem. This is not a good practice. So whenever you will be building a software, you will be following some activities, some preliminary work will be done on that project. So we follow steps such as gathering requirements, designing, implementing, testing, and then maintaining the system. So these are basically general steps which are followed when we are working on a software project. If we take an example and if we compare it with a real-time example, then think of building a house. You don't start laying bricks randomly. You first plan, design, and then construct step by step. In the same way, a software process gives us a roadmap for building reliable and successful system. Now, another important point here is that why is a software process important? Because without a process, development becomes chaotic and unpredictable. A defined process ensures quality. The software should meet the customer expectations, predictability. We can predict, estimate cost, time, and resources of the project. Manageability, it helps us control complexity in large projects. Accountability, every team member knows their role and responsibilities. History shows us that many software projects failed because they had no proper process. So a structured process is not optional, it's essential. So if we take an example that if you are given a complex software project and rather than working on the requirement gathering, you directly start working, then there will be multiple problems you will be facing while you are working on that project. So it is a good practice that you do a small phase of requirement gathering and then you start working on that project. It will ease your complexity of the project. So there are general activities in a software process. The first one is specification, figuring out what the system should do, development, designing and coding the software. So first of all, you must know that what will be the objective of this project, and then you will start the second phase, which is the development, in which you will be working on designing and coding the software. The third one is validation. Once you have completed the development phase, you will start testing to ensure the system works as intended. That system is working according to your expectation, which expectations were set at the first phase of specification. The last one is evolution. Evolution, updating and changing the software as requirements change. For example, if we are developing a mobile banking app, in the specification stage, we should know that what this mobile application should do. So in the specification stage, we decide features like account balance checking and money transfer. In development, we design and write the code. In validation, we test if money transfer really works, and in evolution, we later add features like bill payment or QR code scanning. So evolution phase relates to the phase of working with legacy code, which I discussed earlier when I was mentioning the books which we will be using in this course, working with legacy codes. So evolution phase is related to that phase, that we will be working on existing codes and try to improve that existing codes for our real-time problems. So now these activities can be organized in different ways, and that's where software process models come in. So now, until now, we have defined software process. We have seen multiple activities included in a software process, which will help us to reduce the complexity of our problem. Now we are going to organize the software process activities in different ways, which will lead us to different software process models. A process model is basically a strategy for organizing the tasks of development. Some common models which are used are waterfall model, iterative and incremental model, spiral model, agile model. We will look into the details of each model one by one in coming slides. So if you have a question in your mind that there are four models mentioned here, and which one of these models is the best one to use in software development process, so the answer to this question is no single model is perfect for every project. The choice depends on project type, requirements, risk, and customer involvement. All these factors are included in a software development process. When you are working on a project, you have to consider these stakeholders which are very important for you, and then you, based on these stakeholders, you will be finalizing which model you are going to use. Another important thing is the complexity of the model. We will look into the later slides that which model suits the complexity level of the project. So the first and the oldest model in the list discussed previously is the waterfall model. It is a linear sequence of phases. These phases are requirements, design, implementation, testing, and maintenance. So now, what are the advantages if we use the waterfall model, and what are the disadvantages of the waterfall model? We will discuss this now. So the advantages are it's simple and easy to manage. Every phase is well documented, and the disadvantages are it is very rigid. Once you move forward, it's difficult to go back, and it doesn't work well when requirements change frequently. It is more suitable for projects where requirements are stable, like defense system or space exploration projects. So if we take an example of some real-time projects, we know that requirements are changing on regular intervals. We cannot rely on the tasks or on the requirements which were shared with us 6 months ago or 2 months ago, but these requirements are changing in real time in regular intervals. So for the problems in which requirements are changing in regular intervals, the waterfall model is not a good example of model to be used in the designing or development phase. So we have to go for another model, because in waterfall model, once we have completed a single phase, we cannot go back onto the phase before completing the whole process. We can go back to the initial phase once we have completed all the steps included in the activities in waterfall model. As you can see, there are five activities mentioned. The first one is requirement definition. So first of all, you will complete requirement definition, and then you will go to system and software design. After completing system and software design, you can go to implementation and unit testing. Now, if you have any updated requirement at this time, you cannot integrate that updated requirement at this phase of the waterfall model. You have to complete all the five activities, and then you will go back to the requirement definition. So this is a major drawback or disadvantage of waterfall model. So this waterfall model only best suits to the models which are not very complex, which are very easy to implement, and the requirement of that project is not changing in regular intervals. The next model is iterative and incremental model. Here software is built in small increments. Each iteration produces a working version of the system that can be reviewed and improved. The advantages of incremental model are customer feedback is available early, risk of failure is reduced, the customer sees continuous progress. For example, let's take an example of incremental model. Mobile applications are often released in an initial version and then frequent updates and new features are added into that mobile application. So this is an iteration of a mobile application. The first model, the first phase of application is the first increment, and then you can integrate multiple updates or multiple features in the upcoming iterations of that mobile application. So this is the very best example which suits to the iteration model. And if we take an example of an operating system, operating system does not come to us in a full ready stage, but it comes in an initial phase. Then after some time we receive another update of that operating system and we have to update our system. So that initially we received the first iteration, secondly we are receiving the second iteration, and it goes on for regular intervals, that updates are coming in our mobile phones or operating system, and we have to update our operating systems to enjoy the newly added features in that operating system. The next one is the spiral model, which is a risk-driven approach. It combines aspects of iterative development with systematic risk analysis. Each cycle involves planning, risk analysis, development, evaluation. This model is best for large and complex and high-risk projects. Let's take an example of spiral model. You are developing a new operating system and a safety critical medical system. So you have to look for risk analysis. You have to do the risk analysis phase again and again in this problem. So the spiral model suits very well because in each, as I have earlier mentioned, that in each cycle, the second phase is risk analysis. You have to go through this phase, and then after that you go to the development phase. While in iterative model, we were not going through the risk analysis phase. We were going from planning directly to the development phase. The last one is the agile model, which is very popular today. Agile focuses on flexibility, adaptability. It uses short development cycles called sprints. Its values include customer collaboration over contact negotiation, responding to change over following a rigid plan, working software over heavy documentation. Companies like Google, Microsoft, and Facebook widely use Agile because it allows them to quickly release updates and respond to user feedback. So Agile model welcomes the user feedback in regular intervals, and based on that feedbacks, we continuously keep updating our model based on the feedbacks or recommendations of the user or the client for which we have made that model. So agile model is one of the best example which is currently being used in software engineering because it is very open to feedbacks and recommendations of the user. User or client is the most important stakeholder in your software engineering project. You cannot ignore or you cannot let go the recommendations of the user. You have to work according to the instructions, according to the requirements of the user. So agile model is the best model which is currently being used, which welcomes user recommendations and suggestions warmly, and you have to integrate those suggestions and those feedbacks in the next updates of your so the previous discussion of multiple process models brings us to the very important question that how do we choose which process model to use. We have discussed four process models in our previous slides, like waterfall model, spiral model, iteration model, and the agile model. And we have discussed the advantages and disadvantages of each model. And now we are at the point, this will be a question in your mind, that which process model we should use for our project. So basically the choice of process model depends on multiple factors, which could include size and complexity of the project, stability of requirements, risk level involved, expertise of the development team, and customer involvement. For example, if the requirements of the project are same throughout the cycle, then the best choice for that project is uh, waterfall model. And if the requirements are changing in regular intervals, then we have to use some other model like iteration model or the agile model, because agile model welcomes the feedback of the customer, and feedback means that requirements are changing. User will be changing its requirement in regular intervals based on the results of the previous iterations. So we have to choose another model. So when requirements are changing, the model is complex, so we will use agile model. But if the requirements are fixed throughout the project, then we can use a waterfall model. Another important thing is risk level. If risk level is involved in that project, then we will be using spiral model rather than any other model. So remember, there is no universally best model. The best process is the one that fits the context and needs of your project. So requirement gathering phase is very important, and based on that phase, you can take the decision that which process model best suits to your project. Okay, so this brings us to the end of today's lecture. If you have any queries, if you have any questions, you can ask me through email. As I have earlier discussed about consultation, if you have any confusion, you can consult me through email or you can visit me in my office during the consultation hours. Later on in this course, we will be studying the software development life cycle. There are multiple activities which are involved in software development life cycle, and how we are going to use those activities to ease the complexity of our project. So that's all about today's lecture. I hope you would have got each and everything I have explained in this lecture. Still, if you have any questions, you can ask me. Thank you very much.